First, we're going to use the rational zero theorem to determine the possible zeros. So what we're going to do is we're going to use that 15 for the p. And so we're going to say, okay, p equals plus or minus the factors of 15. So those are 1, 3, 5, 15. And then what will be the coefficient to use for q? 1. So the factors of 1 are plus or minus 1. Now, when I do p over q, it's plus or minus all of these divided by 1. So it's plus or minus 1 over 1, which is 1, 3 over 1, 5 over 1, 15 over 1. So are those numbers the same as p? They are. Meaning, whenever q, that coefficient is 1, p over q is always going to be the same as your p's. So if you want, you could just skip that motion entirely and just go straight to p over q. It's a little bit of a time saver. All right. Next. This function has a degree of 3. So how many possible zeros is it allowed to have? 3. Right? 3 or less. In this list, I have how many?
4.
Not 4.
8.
8. I have 8 of them. Potentially, 3 of those could be factors, could be zeros of this function. The way I'm going to test them is this. I have 8 numbers in that list, right? I'm going to do synthetic division with every single one until I find one that gives me a 0. Okay? So guess what though? You know what? I'm gonna be a rebel here, and I'm gonna start with a 2. Okay? Don't write this just yet. Wait, don't write this just yet. Just to show you that you don't have to go in order. You have to go in any order. You can go in any order that you want. So, 2 isn't. What is?
3.
A 3. All right, let's do 3. Let's do 3. So I have 1, -3, -13, 15. 1 comes down, and then I have 3, 0, 3, 0, -13, -39. Is that going to be a 0? No. So then you move on to another one and see if it works. You move on to another one to see if it works. So it's a little bit like the lottery. It could happen that the very first one you try will work, or it could be the 5th one that you try that works, or maybe the 12th one if you have a bigger list. And I do recognize that it's very time consuming. So what we're going to do is we're going to eliminate this trial and error by hand. And instead, I'm going to let you use your calculators to get that initial 0 and go from there. So what I want you guys all to do is I want you to take out your calculators. Mine is still not working, so I'm using my old one. And I want you to graph that function. Oops, not this one. I want you to graph x cubed minus 3x squared minus 13x plus 15. I want you to graph it, and it will look something like this. So you don't have to choose any point. You're just visually going to examine this graph. Okay? Are you guys with me? You're going to visually examine this. You're going to visually examine this graph and just pick one of the points. So right now, you know what? I'm just going to choose to take that one, which crosses the x-axis at x equals 1. Okay, so that's the one I'm going to take. When you do that, then you're going to do your synthetic division with x equals 1. So you see, the only thing I use the calculator for is to find one that works to eliminate trial and error. So now, 1 comes down, and I get negative 2 here, negative 2, negative 15, negative 15, 0. Should we have gotten 0 remainder? Yes, because it's a 0. Okay. Now, I'm going to use these and rewrite f of x. From this term outside, the 1, I'm going to say 1 factor is x minus that number 1. Always minus. So if the number outside was a negative 2, it would have been x plus 2. And then from here, I get the depressed polynomial. X squared minus 2x minus 15. And I'm going to set it equal to 0. Okay. Now, factor the blue. And we're going to get x minus what? X plus 3 equal to 0. So now I see that x equals 1, x equals 5, and x equals negative 3. So those are the 3 zeros for this function. All right? And, okay, the minute we graphed, we knew all that. Because graphing is a spoiler alert. It gives us the final answer, right? But the only reason why we're using the calculator is in order for us to eliminate that trial and error. So we do that, we pick the 1, and then we go from there. So especially if you have your calculator available to you, I'm going to be looking for the work more meticulously. Okay? All right. Let's do one more function. But this time I haven't broken it down into steps. We're just going to do the whole thing in one part. All right. So first, we're going to do P over Q. For P, it's the factors of 15, which we've done before. 1, 3, 5, 15. For Q, it's plus or minus the factors of 2, 1, and 2. Okay. So then P over Q is plus or minus 1 over 1, 3 over 1, 5 over 1, 15 over 1. And then all of them over 2. 1/2. Yeah. For which one? These are the factors of 15. So how do you get 15? It's 1 times 15 and then 3 times 5. So these are all the P over Q's. Now, how many in this list? 8 times 2 is 16. So you would have to do, synthetic division a whole bunch of times. But we're using our calculator. So let's go ahead and graph that function. And because they look so similar, I could just edit my first one. So it's 2x cubed minus 5x squared minus 28x plus 15. Enter. Graph. Hey, look at that. Okay? Now, if you're not sure what point that one is, like it looks like it's between the 0 and the 1, just don't go for it. Go for a whole number, right? If you have those options. So look, I have a negative 3 and I have 1, 2, 3, 4, 5. Which one do you guys want to do? Negative 3 or 5? I hear a 5. Let's do a 5. It will all turn out to be the same no matter which one you choose. So let's do a 5. And I have here 2, negative 5, negative 28, 15. 2 comes down, 10, 5, 25, -3, -15, 0. Okay, what happens if you don't get a 0? You did something wrong, right? Because if you picked the point from the calculator correctly, then something went wrong in the math. Okay, it must come up to a 0. So now I have here, from this outside number, x minus 5. And then I have 2x squared plus 5x minus 3 equal to 0. Yeah, you know what? I'm actually going to rewrite that here. Okay, so I'm going to factor that second part. Move the 2 out here. So what am I going to get? X squared. And then when I factor, it's x minus 5 and, sorry, it's x minus 6 and x plus 1. Nope, other way, x plus 6, x minus 1. Okay, then you put the 2 back and you divide by 2. So finally, from way in the beginning, I have x plus 5, I'm sorry, x minus 5, x plus 3, 2x minus 1 equal to 0. Okay? Now what? From here, x equals 5, x equals -3, and this, yep, 2x equals 1, x equals 1/2. So you have, here we go, all 3 of your zeros. Okay? All right, next, we're going to talk about Descartes' rule of signs. How many of you guys have seen this before? In Algebra 2, in Intermediate, have you? Maybe. Okay, so who was Descartes? Descartes was a mathematician, a French mathematician, and he was also a philosopher. He gave us many, many things. He's the one that said, I think, therefore I am, right? And then also, the way we set up our x and y axes, right? That grid that we make, you know what that's called? That's called a Cartesian coordinate plane, or a Cartesian coordinate system, named after René Descartes. So he's huge. Lots and lots of things are credited to him. He also gave us this thing called a rule of signs, and basically, more than narrowing down the zeros of a function into a list, it now gives us more information about how many positives and how many negatives there can be. Okay? So, let's do this. Here's what we're going to do. We have a polynomial. This is the polynomial we're going to work with. We want to determine the number of times the coefficients alternate signs. So, look at the coefficients here. +1, -3, -5, +2, +7. So, how many times is there an alternating sign between the coefficients? This was positive, it goes to negative, so there is 1 there. Then it stays negative, and then another one where it changes from negative to positive is here. Okay? So, the number of times that it alternates signs is 2. Now, we're going to take this number and we're going to subtract from it multiples of 2. So, I take the number and then I go -2. What do I get? 0. You keep doing -2, -2, -2 until you're no longer able to subtract 2 and get 0 or a positive number. So the minute you're going to start getting negative numbers, you stop subtracting. So, what if it wasn't a 2 but a 6? What would you do then? Then you would get 6 minus 2, you get 4, minus 2, minus 2. What if you got a 5? Then you get minus 2, you get 3, 1, and then you stop. Am I making sense? I am to me. Am I to you? That's very rare. Okay, sometimes I just don't make sense. Okay, now we need to find f of negative x. Okay, check out what we're going to do. We're going to take each of these x's, replace them by a negative x, and then simplify. So, f of negative x is going to be negative x to the 4th minus 3 negative x to the 3 minus 5 negative x squared plus 2 times negative x plus 7. Okay, so now let's simplify. Negative x to the power of 4. Do I end in positive or negative? I have like 2 conflicting answers. So if you have a negative number raised to the power of 4, it's negative times negative, negative times negative, positive. If it's an even number, it's positive 4. Minus 3 times negative x cubed minus 5 times positive x squared minus 2x plus 7. Finally, f of negative x is x to the 4 minus minus is plus 3x cubed minus 5x squared minus 2x plus 7. Okay, so you know what? That was a little bit more work than I'm usually willing to put in. Okay, let's see if we can make that any quicker. Let's compare original to f of negative x. Okay, I have even exponents, I have odd exponents. Let's look at even exponents. Positive stayed positive. Negative stayed negative. Okay? Now let's look at odd exponents. X to the 3, 5, 1. Odd exponent, negative. Okay, it switched. Odd exponent, positive. It switched. Okay? So in doing this, if you have even exponent, same sign, right? You get the same sign. If you had odd exponent, you get opposite sign. Constants, same sign. So the next time we do this, we can do it a little bit more quickly. Okay, now we're going to do the same thing. Number of times these coefficients alternate sign. So let's see, I have positive, positive, whoops, switches to negative, switches to positive, so twice. Okay, subtracting 2's, what is going to go in that box? 2 and 0. Now, I need to pair up all the combinations. So I have 2 and 0. These are the possible positive zeros. And then I have 2 and 0. These are the negative ones. So imagine I have red team with 2 people on it, green team with 2 people on it. And now each of these team members are going to play against each of these team members, right? So let's do all the pairings. The red 2 plays against the green 2, and the red 2 plays against the green 0. What other combinations? What other combinations are there?
0, 2, 2,
Red 0 with the 2. Red 0 with the 0. Cool? Okay, now, how much is the degree of this function? What's the degree? 4. That means, how do you know that? Highest exponent. So each row must add to 4. So now I need to go add up each row and see how many I'm missing to make it 4. Okay. First row, 2 and 2 makes 4. I don't need to compensate anymore. I don't need to put any. 2 and 0 makes 2. I need to compensate with an additional 2. 2. And how many for the last row? 4. This is how many positive zeros this function will have. It can either have 0 positives or 2. How many negatives and then how many imaginaries. One last word is this column can only have even numbers. This is the number of imaginary zeros. Imaginary numbers always walk around in pairs. You can never find a lone imaginary 0. It's never a possibility. Because they come from something being squared, like x squared equals -3. You take a square root, you take a square root. When you take a square root of both sides, it's always x equals what? Plus or minus something. So from there you always get 2. We'll do more tomorrow and you'll see. Okay? Now, I'm actually going to stop here for today. Yes.